Good evening to dear students of class 11. Let us continue the chapter number 2 with the topic of velocity time graph for the motion of a body. I am Dhanusaria and will be explaining you the various types of graph for different conditions of a moving body. So keep watching the video till the end so that this concept is understood very clearly and you can correlate the graph drawn with the condition given, because in the exam condition may be given, graph can be asked, or graph may be given, condition can be asked. Vice versa, both these conditions you have to understand very carefully how to draw the graph with the help of conditions given to you. So if you are new to this video, please like, subscribe and share my video so that every concept is understood by you very clearly. Now we move to the topic velocity time graph, which is in short called as a VT graph. Okay, so VT graph full form is velocity time graph. Fine. Now here I have arranged two types of graphs. We have 3 pages in this video where all the 3 pages we will be talking different types of conditions and their respective graphs. So keep watching till the end. Now here we have motion in positive direction with positive acceleration. Now what is the meaning of the word positive direction? Positive direction means the body is moving forward. Positive acceleration means what? Let us see through the formula. What is the formula of acceleration? Instantaneous acceleration. Final velocity minus initial velocity upon time taken. So V is the final velocity of the body. U is the initial velocity of the body. And in the textbook, U is denoted as V naught. But normally we use U as initial velocity, so to make it easier for us to remember V and U very clearly, instead of saying V naught is the initial velocity, we can just say U is the initial velocity. Fine? Okay. So now you can see for positive acceleration, we will get a positive answer for acceleration only if V greater than U. Okay, so if final velocity is greater than initial velocity, only then the acceleration will be positive. And in present condition, our body is moving in the forward direction. So now for the given conditions, let us plot a graph of V greater than U. Fine? So that we can understand how to draw the graph. It is a straight line where we have selected 2 points U and V on the y-axis and the time on the x-axis. Fine? Okay. So now here we have V. Okay. So this is what we have. Okay. So this is a kind of a graph which has positive acceleration, positive direction. Fine? Okay. And here you can say that the slope of this graph can give me the acceleration itself. What kind of a graph it is? It is a straight line graph. And what type of a slope it is? It is a positive slope. Fine. So given one condition, the other conditions should follow, either looking at the graph or looking at the conditions given to you. So if it is a positive acceleration, positive direction, then the graph is this. Slope going upwards. Straight line going upwards. Slope is positive, definitely. How do you calculate slope? The y-axis coordinates, y-axis ordinates divided by the x-axis ordinates. Simple. That is the way to calculate a slope. So now we move to another condition where the motion of the body is in positive direction but with negative acceleration. What is the meaning of positive direction? The body is moving forward but acceleration is negative. It's just like you are going in a vehicle and then suddenly the brake is applied and the particular vehicle has stopped. So in that particular motion of applying the brake and the body or the vehicle is stopping, you were already with one initial velocity and the body has stopped. So final velocity has become 0. Fine. Okay. So in that condition, how do I draw the graph? I am in a vehicle, I have applied a brake and the vehicle has stopped. So final velocity is 0 or less than the initial velocity. So if at all the acceleration has to be negative, then u is greater than v. Initial velocity is greater than final velocity. Acceleration formula is written as v minus u by t, but the answer is negative because u is greater than v. So such a negative acceleration is also called as retardation. Fine. So how do I draw a graph in this case? The graph in this case will start from a bigger value of u to a lower value of v. Agreed? Okay. So this is the graph that can be drawn for a negative acceleration. Now as can be seen here that the value of u is greater than v. Fine. Okay. So the slope is also negative and the graph is a straight line graph. Okay. If I find out the slope here, I will get a negative slope as I have written here. Fine. So here I can say that the final velocity is lesser than the initial velocity for a longer time, say t1. Clear? Or t2. Fine. So this way, looking at the graph, you should be able to identify whether the acceleration is positive or negative. Direction is positive for both. Body is moving in forward direction for both. But here final velocity is greater than initial velocity. Here initial velocity is greater than final velocity. This is acceleration. This is retardation. Fine. Okay. So understand the concept very clearly with the graph and the conditions given to you. I just move, you just take a pic of what we have done just now. Then we will be moving to the next page. So now we move to the next condition of the velocity time graph, where we have negative direction, negative acceleration. Fine. Negative direction, negative acceleration. Negative direction means the body is going backward. Okay. Negative acceleration means you have a retardation, and definitely u is greater than v. Only then you will get a negative acceleration. So how do I draw this graph in this case? In this case, I shall draw a graph which is starting from u. It is on the negative y-axis, so both are negative. Fine. Okay. And we get this kind of a negative slope, negative acceleration. It means it is a retardation. Let me point out this particular. Okay. Fine. So here also u is greater than v and the body is going in the negative direction. Fine. Okay. So it is also like you're taking a body in the reverse direction. You have already started and you're taking the body in the reverse direction and you have stopped it there. Reverse parking. Such a type of example you can keep it in the mind of any object. Fine. Okay. So here also it is a slope. It is a negative slope. Okay. Slope. Negative slope. U greater than V. And because the direction is negative, we have plotted this graph in the fourth quadrant of any graph paper. Fine. So remember, negative direction you have to draw in the fourth quadrant. Negative acceleration, u should be greater than v. Break the condition into two parts. Okay. So where have you drawn it? In the fourth quadrant of a graph paper. Okay. This is the first quadrant. This is the second one. If I extend this, this is the third one, and this is the fourth quadrant where y-axis is negative and x-axis is positive. Time is positive. Time is definitely going to move forward only. Is it clear? Okay. So this way, all these conditions you must remember. Negative direction, negative acceleration. Negative acceleration means retardation. Draw it in the fourth quadrant. Fine. Now let us move to the next condition. Negative acceleration but changes the direction. Now at certain time, say t1, what should I do? Changes the direction means what? Initially it is going in the positive direction with a negative acceleration. So how should I draw this graph? Changing the direction at t1. So what I will do? I will go straight from here. At the time t1, I will go in the fourth quadrant. Agreed? So that this is the final velocity I get. Okay? Fine. This is what I get. So now you can see that at the time t1, the graph is drawn in the fourth quadrant. So what happened? Its direction changed at t1. So what should I write here? Direction changed. At t1. Okay. What was the direction first? Positive direction. That's why we drew the graph in the first quadrant. So this much portion is positive direction, negative acceleration. Agreed? From here to here. What is the path? U to T1. Then in the fourth quadrant, when the time has reached T1, that time the direction is negative and acceleration is also negative only. Clear? And what is its path? Its path is T1 to V. Agreed? Okay. So this way, first the direction was positive, then the direction is negative, but in both the cases, the acceleration is negative. So slope will be negative, whether in the upper portion of the line or lower portion of the line. Fine? Okay. So this particular graph is a combination of the second graph or the second condition which we drew here and the third condition which we drew here. It is a combination. Positive direction, negative acceleration. Negative direction, negative acceleration. Clear? Okay. So throughout the journey, acceleration is negative, but direction is changing from positive to negative. Then this kind of a graph you will get. Clear? So just take a pic. I hope you have understood what are the concepts. Now in the next page, we will again go to a graph, and from that graph, we will understand what we can find out using a VT graph. So keep watching till the end. Take a pic of what we have learned just now. So now let us see at the topic of area under velocity time graph. Understand it very carefully and let us prove it also for a body moving with the velocity u as the time goes from 0 to t. Fine? Okay. So let me draw this graph such that we have a velocity time graph with q is equal to same from time t is equal to 0 to time t is equal to t. The velocity is remaining the same. Now, as you can see, one rectangle is formed here. Every rectangle will have an area. So, let us cover this area or find out the value of this area. Okay. So, what is the value of this area? This much is u and this much is t. What is the formula of area of a rectangle? It will be length into breadth. What is the length? T. What is the breadth? U. So my answer is UT. But what is velocity into time? What is our formula? Velocity is equal to the delta x upon delta t. Change in the displacement upon or displacement upon time. So displacement delta x is equal to V into delta t. That is what we have here. Velocity into time, time interval, velocity u. So what is this delta x? Delta x is displacement. Agreed? Which is equal to v delta t. So this is also u into t. So this also should be displacement only. So what is this? What does this mean? This means that area under the graph, as it is written here, area under the graph. Which graph? VT graph, not any other graph. VT graph will give us the displacement of the object. Okay? So using this formula or the equation, remember that area, this was only the graph. This graph we got. For what condition? When u is same from t is equal to 0 to t is equal to t. The value of u remains same as time goes. We got a straight line parallel to time axis. We got it. And then we closed the figure and converted it into a rectangle. Found the area of the rectangle, which is ut, which is given to us as displacement. So we concluded that area under the graph, any kind of a graph, whether it is parallel to the time axis, whether it is inclined to the time axis, will give us the displacement of the body from the time it started till the time it ends the journey. Okay, so similarly, if we go to the previous pages, if I want to find out the displacement of this body, then how much area should I find out? This much area. This area of this portion, it is a trapezium. You can see here. Okay, with two sides parallel to each other. So area of this trapezium will give me the displacement of the body in that particular time. Agreed? Same way here. This is my graph. So I have to calculate the area of this portion geometrically. You can see one triangle here, one rectangle here. Add those areas. That addition of the areas with the values will give me the displacement. Go to this graph. Here, this much portion. How is this much portion? This is also a triangle and a rectangle. It can be considered as a trapezium. So area of the trapezium will give me the area, will give me the displacement for this particular time. Here also the same thing. Agreed? This much area plus this much area will give me this area, and this area will give me the displacement of the body. Followed? Okay. So area under the graph, let it be a curve also. Then also area under the graph will give me the displacement of the body for its motion from the initial time to the final time. Clear? Okay. So I'll just move and you take the pic of what we have done just now and understand the concept, and remember that area under the graph PT graph will give us the displacement of the body. Fine? Okay, I'll just move, you take a pic. And this particular concept we are going to use in our next derivation, which is the most important derivation of this chapter, equations of motion using a graph.